The AgEmerge podcast is brought to you by Ag Solutions Network. I'm your host, Monte. Join me as leaders in soil health, research, and ag tech share their perspectives and enable you to farm outside the box.
Are you ready to immerse yourself in the future of soil health? Don't miss your chance to register for the 2025 Big Soil Health Event, happening December 8th and 9th in Cedar Falls, Iowa, hosted by Soil Regen. This event is all about farmer-first education, training, and networking to boost soil health, improve your quality of life, and maximize your ROI. After the event, they'll stick with you every step of the way through consulting and community support. Don't wait. Join us for inspiring speakers and an incredible community of attendees that will keep you learning and growing. Head over to www.agsoilregen.com to register now. We can't wait to see you there.
You blew in from Minnesota today.
I did.
You're getting all around the country, working with farmers, talking to them, answering lots of questions. And the reason you're here is we had a customer at one of our events said, I had this Haney Soil Health Test. And said, it seems really cool, but I have no idea what it means. So I called up somebody by the same name, and I thought, probably should know a thing or two about it. And we had a great Zoom call. And I said, you know what? There's a lot of people know about or have questions about the Haney Soil Test, but We're going to take some time and just go through and explain the Haney Soil Test one-on-one, the kind of a walkthrough. So I'm excited.
Yeah.
Okay. So first, you got to tell us the history. Everybody likes a good story.
Yeah.
So, I mean, let's go way back to what was kind of the inspiration for was it frustration with the old school soil tests? What started this journey into looking into analyzing soil from a plant perspective more?
So Rick grew up farming for some family in Iowa and then in Oklahoma. And then when he was about, I think 15 or 16, he got hired on as a farmhand in Oklahoma. And so he farmed forever with one of our good friends, C.R. Christensen, and could just see all the struggles that he had. Control over the commodity market, weather, blah, blah, blah. So he wanted to go back to school and help farmers like CR be more profitable. And Rick is a huge fan of nature, and he didn't grow up in an academic background at all. So he came in looking at everything completely different from his observations in the field and farming and all that. So that's what inspired him, was trying to help out farmers.
Yeah. So now tell me how you guys got connected and the lab work and all development of all this. I mean, there's to start, you really started from scratch on a lot of that.
Yeah. So during his master's degree, Rick did a lot of stuff on CO2 evolution and nitrogen mineralization. When he went back to get his PhD, I was going to get my master's degree at the same school, Texas A&M. And my major professor and Rick played golf together all the time. And my major professor went up to Rick and said, don't touch my new grad student. She has a big redneck boyfriend, on purpose, because he knew then that Rick would come and talk to me. So that's how we met and the whole thing started.
Well, that's a funny story.
Yeah.
So you were there. What was your master's work in at that time?
So my master's work, I was doing studying acid forming materials and surface mines.
Okay.
So a little bit different than the biological stuff.
Yeah.
Yeah. But once I got out of school and went to work in mine soil reclamation, Rick and I applied a lot of the testing and the theory and the dynamics behind when we were making reclamation plans and seeing if they were working. And so we did incorporate it into that as well.
Well, a lot of reclamation plans have biology as a component of it too.
Yeah,
right?
back then they didn't really.
Oh.
Not from a soil perspective.
Okay.
No.
Okay.
No.
But I know some of the well reclamation stuff that they do in Texas has a lot of biological components.
Yeah, well reclamation does, but the surface coal mine didn't at the time.
All right. So this trying to understand how a plant, so you take a farmer perspective, right? And you apply this to trying to get a better understanding of what's going on in the soil. So it led to, we're going to dive into each one of these individually a little bit, but a different way to extract nutrients, right? So
Yes.
today there's primarily two different ones, neutral ammonium acetate and Malic 3.
Right.
And that's kind of what the industry or whatever standard is. But H3A extract, just high level, why is that different?
So it's different because it's based on plant root exudates.
Mm-hmm.
So the three most common plant root exudates that are found in row crops, basically. And that's because when plants are growing in the ground, they pump out these organic acids and dissolve minerals, and that's what's plant available.
Mm-hmm.
So in Texas, we have really, really high pH soils.
Mm-hmm.
They went to using Malic 3 to extract phosphorus, and we were seeing massive amounts of phosphorus deficiencies in the field. And so that's another driving factor, wanting to get the actual correct answer for the farmer so they can be the most productive they can.
Right. So shouldn't anybody that uses Malic 3 on a 7.5 or above pH just be shot? You don't have to answer that. I'll say that, but anyway, no. I will say, but I will say this: Malic 3 was developed on the coastal East Coast, not washed soils, so typically lower pH and older soils that just don't have, the same characteristics at all compared to theirs. Nerd out on us a little.
Correct.
Okay. Oxalic acid is one of them.
Yes.
And that's the stuff that's in kale that makes you itchy, by the way.
Did not know that.
Don't eat kale. Oh, that's another topic. Oxalic acid.
I love kale.
That's your problem. No, I'm just joking.
One of them.
Our T-shirt, and
there's so many.
We're going to get you one of these T-shirts that says "Our cows eat kale," so
you don't have to. Yeah.
So that's why we plant kale for our cows to eat. So oxalic acid. What's another one of those?
Malic. MALIC.
Yes. And the third. Very good. You mean corn makes citrus? How does that work?
It's citric acid.
I know.
Yeah.
Amazing. So those acids how are they different? I mean, give us a little chemistry lesson on that.
Okay. So the difference is that these three acids aren't buffered.
Okay.
So Malic 3 is buffered to a pH of like 2.5.
Okay. So it's a strong acid.
It's a very strong acid.
And it keeps by buffered means it stays at that.
It stays at that. So no matter what soil pH you put it in, it's going to drop the pH level of that soil 2 to 3 points regardless because it's so acidic.
So if you're starting with a 5.5 or 6 pH soil like you might have in the East, dropping it down to that 2 is not that much of a change. But like a 7 or 8 pH soils that we might have in the West, that's a big change. Is that?
It is a big change. But even in acid soils, what we see is that Malic 3 will dissolve iron and aluminum phosphate, which aren't plant available yet or readily for that season. And then higher pH soils, it dissolves calcium phosphate. And that's why in Texas, we were seeing the phosphorus deficiencies down there.
Yeah, because calcium phosphate is very hard to become plant available.
Right. And we have like 2,500 part per million calcium, pH 8.5 soil.
A lot of calcium carbonate.
We're on limestone.
And sodium bicarbonate maybe when you're dealing with well water addition.
Yes, for sure.
Okay.
Yes.
So we're doing things that the plant can't, but these other three acids that you're using are not buffering. So in other words, they react and they're done.
They assume the pH of the soil or within a 0.5 to a 1 point, depending. So we're not falsifying basically the strength of these acids in your soil under your conditions.
So can we go into, are we allowed to tell about the soil lab's dirty little secrets on Malic 3 and calibration numbers?
Sure.
Can we?
We can say anything we want.
But typically there's calibration numbers that they run on a Malic 3 test back to on phosphorus, like you're saying, Bray, or more of the standards. And the calibration number can change over time to kind of match back to standards. Isn't there some fudging that happens from within the lab to keep the calibration constant?
Well, the laboratory methods, it's, Malic 3 is a standard chemical. And so you're calibrating instruments in the laboratory. You're not calibrating a soil test in a laboratory.
So you're calibrating what those sensors pick out of that solution that has...
Right, based on a standard where the amount is known. The calibration of soil tests in the field, calibration, I want to point that out, not really calibrated. It's based on yield, crop response to fertilizer additions.
So
under a conventional management system.
Fertility...
in a few places on small plots.
Not just on a few places, small plots at land-grant universities.
Yes.
Okay. So you're saying they don't have a wide correlation?
Potentially.
Or you're extrapolating it over, you're assuming small plots to a large area.
Correct.
Okay. I'm trying not to get her in trouble here, okay? So realize some of this is me getting her in trouble.
I'm my own boss. It's fine.
Yes. Yes, she is. So so what was that process like discovering that, those mixtures, those acids and making that all work? I mean, the time that took to...
many years.
...figure out has to be astounding.
It took many, many years and many iterations. And then where we really nailed it home is we tested it against iron aluminum oxide strips, which is the gold standard for phosphorus availability. But it's not practical to do in a lab because it's expensive and time consuming and nobody ever get their numbers. But it is the gold standard. And we had basically a one-to-one relationship with phosphorus availability with our final formulation. Malic got out about 2 times the amount of phosphorus that was available. Unless you included really high pH soils, then it was about 2.5 times.
Bray, Olson, do you know?
Yeah, we did it with Bray, but I can't remember the number off the top of my head.
Fine. But that's interesting to see that it's calibrated that closely. So that's one part of it. And then really the water extract part is another new approach. Correct?
It's been raining water for a long time, but yeah.
Are you serious?
Yeah. It's a new approach to a laboratory, not nature.
Been raining water for a long time.
Yeah,
that's true. So what are you trying to tell me here, Liz? That plants take in nutrients with water?
Yeah, yes, and microbes respond to water, their activity,
and we need to drink water,
and we need to.
So all of life revolves around water.
All of life
might be somewhat important to see how the soil functions in that way.
Yes.
Why is this ignored by? How did that get to be just almost, other than maybe pH?
Yeah.
How did that historically? Why was that just ignored?
So most laboratories, like to extract nitrate nitrogen, they use KCl, really dilute solution, and potassium chloride solution. And that was to clear it up so that the instruments could read it better. But it's not what the actual soil sees when it rains.
You don't rain free
it doesn't
potash?
Rain. No, it doesn't rain free potash. I'm sorry.
Darn it.
I know.
Really great. If
that would be good. Yeah.
So it's just those kind of unintended consequences change results.
Yes.
What are some other things that you think are just, when you think about big picture, really unique about what you're doing?
Well, we measure, the microbial activity, which is very unique.
Oh, that's another one.
We use water for that. And we use water to measure water extractable organic carbon and water extractable organic nitrogen. And I think in my mind, those are the 2 most important parts of the test that I look at.
We are,
or those 3. And respiration.
Are you allowed to say it like that?
Yeah. We on.
Okay. I was just making that up.
No, that's what we say. We say that all the time.
So now I'm like part of the club?
You're in.
Oh,
you're in.
Man,
yeah, I know.
So
feels good, right?
Yeah, it does. So tell me so water extractable organic carbon, water extractable organic nitrogen. Okay, why is that such a step forward in our understanding of what's going on? Because you're saying it's not just dirt and water in the soil. There's an intermediary.
Yes. And then there's an intermediary between soil organic matter and the food source for the microbes, which is the WEOC, the water extractable organic carbon. And we weren't able to measure it before, and we developed the instrumentation. We didn't develop the instrumentation, but before the instrumentation was developed and then applied to this.
So the WEOC is saying, okay, now how much food do we have for the microbes?
Mm-hmm.
And then WEON.
WEON is the water extractable organic nitrogen, which is associated with that carbon. But plants actually prefer to take up organic nitrogen over inorganic nitrogen because they can use it more efficiently.
Okay.
With less energy.
So then that gives you an idea of, you can kind of model the nitrogen availability curve, the efficiency of the nitrogen that you have in the soil.
You could look at the efficiency for sure. And as soils become more healthy, the organic nitrogen numbers go up in comparison to inorganic nitrogen.
And because they like that organic nitrogen version more, they're going to have a better utilization of it. Therefore, your total applied
will be less, and you'll get optimal results from the organic nitrogen.
And because there's plant health implications too,
Correct.
In organic nitrogen versus nitrate nitrogen. Nitrate nitrogen is it's a bugger when it comes to plant. Sorry, that's not a better word to use, but I mean, when it's a bugger when it comes to tissue diseases. In particular, I know on specialty crops, nitrate nitrogen, especially when you're in the West in high pH soils, you tend to have more nitrate in the soil. So that drives a lot of the leaf tissue diseases.
Okay.
So if we can get more of that nitrogen in the organic form, then that means less
of those problems, plus less groundwater pollution. And
okay, talk about that, because it's bound with organic. It's not going to leach through the profile.
Right. It doesn't leach through like nitrate nitrogen.
And that is, WEON is essentially a result of microbial cycling.
Yes, it's a result of the microbes eating that water-soluble organic carbon source, and that's where the organic phosphorus comes from too. So a lot of people just think, oh, it's just organic carbon floating around, but it's got nitrogen, phosphorus, magnesium, manganese, all these different things associated with it that as the microbes chew on it, they release to the plant.
Are they releasing that as a waste product, or is it basically through their life cycle? And when they die and the single cellular explode, then that's the source, or is it both?
I think it's both. And
do we know?
I don't know that we know.
Can we?
I used to think we could know until I met Dr. James White. Yeah. And who does rhizophagy.
That'll blow your mind, was it? On a side note, I happened to read his paper. I was looking through this summary of journal articles, and I caught this one thing in the very bottom. So I remember it now. It was the third column at the very bottom, and I read this and I thought, well, that's interesting. So I clicked on the link, and I went through and read his paper, and I thought, wow, we got to get this guy in front of farmers. So we invited him. He was at the very first AgEmerge conference.
Nice.
In 2019, and he'd never presented that information to a farm group.
Wow.
Because Rutgers, as you well know, is obviously a worldwide known agricultural university.
Sure.
Yeah. And
everybody thinks that way.
But it was really funny because then there were several other people that were at that same conference, and then they kind of spread his name around. Now he's got a book out. And
oh yeah.
Okay, he's a rock star.
He's a rock star.
So anyway, when's your book coming? Not rock star status just yet?
No.
Oh, okay. We'll keep working on it. But anyway, so, there's a lot of things. The more the time goes by, the more we know that we don't know about the plant and the microbe interface.
Yes. Yeah.
But so it's so important because when you measure WEOC, it's the food source for the microbes in the soil.
Correct.
And that's going to basically drive the WEON. And the WEON is it takes the least amount of energy. It is the least susceptible to environmental pollution, and it's stable, and it's preferential to the plant to where you get nearly 100% utilization from the plant. By looking at those two numbers, that's what you go to first to know what magic's happening in
and with the microbial activity, for sure.
And that's the CO2.
respiration.
Talk about that.
So microbes take in oxygen and give off CO2. And so the more active they are and the higher their biomass, the more CO2 respiration you're going to get from soil after 24 hours.
So if you put a bucket of soil in this room that was highly active microbes, you wouldn't live as long as a bucket of soil would.
No, but your plants will be happy.
Oh, that's true. Well, these are fake plants.
Well,
don't tell anybody. So I think bottom line, the Haney, quote unquote, Haney soil test is far more than just the soil test that what we thought of just wet chemistry. You know, we're just looking at elemental, and we've used that forever, but it's so multidimensional.
Yes, it's more holistic.
Holistic. That's a cool word. Hard to spell, but cool. It's easier to spell than regenerative, right?
Yeah. And to say.
And what?
It's easier to say.
It's true. So anyway, I think as we spend some time here, we're going to go through some soil samples that Kim has from her own farm. Liz is going to put together some examples. I'm going to ask you to put maybe a sodic sample out there, a saline sample.
Okay.
For some of our western half of the U.S. producers to see how that relates there. But we really want everyone to have a better understanding of this phenomenal tool and how you can utilize it on your farm, and why it gives you a better view from all directions of what's going on in your soil. Because once you have that, then you have a tool. Then you can't manage what you don't measure. So as you measure this, you can see how your management changes are improving the soil, which ultimately reduces your input costs. And it becomes I bet you see these things that they're almost like some of these soils are flatline when you start.
Yes.
Working with. But is it a curve that once things get started, it starts to snowball and improve? After a little bit, it starts to improve quickly?
Yes, depending on the practices.
Okay.
So, I mean, the more soil health practices that you implement, and I'm not saying go out and buy cattle, but
full tillage, never cover crop, moldboard plow as much as possible.
Yes.
And continuously crop the same crop, like continuous cotton.
Yeah.
That's what really makes it happen, right?
Oh gosh, that's just yucky.
So what you're saying, the more that you can do, no-till, keep the cover on the ground, keep a living root diversity, and even get crazy with cows, you really see those soil health indicators change quickly.
They do, yes. And the additional organic matter, if you can't have cattle or livestock. So
yeah, okay. Well, it's going to be fun diving into this. Appreciate you coming and spending time with us.
Thank you.
So we're going to we'll take a look here and go through each section of the test little by little and dive in, and then we'll have a feedback way that we can answer questions that you might have. But I hope this time that you spend with us here learning more about the Haney Soil Test will allow you to incorporate it on your own farm. So thanks for spending time with us. We're going to have fun.
Thanks.
Thank you for joining us again. We're back with Dr. Liz Haney to talk a little more over the Haney Soil Test, and we reviewed some of the history and the reasons why behind the test there in our last episode. But I wanted to dive in. We're going to a little more to the mechanics of it, how it works and such. But I think one thing we have to address is a lot of places are doing a Haney Soil Test today. And there's a choice of labs that every farmer has, and I know we can submit to, Midwest or Ward or several others that run a Haney protocol to make a Haney test. But what's maybe the differences in that versus a complete Haney soil health analysis from Regen Ag Lab?
So Regen Ag Lab is doing the whole suite of tests the way that it was intended and published and developed. Whereas a lot of the other labs, and I don't know about every single one of them,
right?
But I do know that a lot of them are just picking and choosing parts of the test, or using outdated technology to determine the numbers. So we always send our stuff to Regen Ag Lab.
And plus, you happen to know a person there. Well, both. Well, everybody at Regen Ag Lab, but one really well, right?
Yeah. Yeah. So, and this is a common misperception. And I got asked this 2 days ago that we don't make money off the Haney test. it was developed with the government, so it's public property. And we're not part owners in the laboratory. That gets thrown out there a lot, and it's just not true.
I never even thought to bring that up, but yeah, it was developed with Rick's time at ARS, right?
Yeah.
So it was developed under USDA ARS, and the protocols made available, public domain, like you said. So, any lab can do it, but there's always a difference in how labs actually do things. And
Right.
I think it's not Regen Ag Lab. The nice part is they're looking at everything that we'd want to test from a soil health perspective. Now, Rick is a technical advisor, right?
Yes. Rick,
to-
their chief scientific officer.
Okay.
So he does work for Dr. Lance Gunderson. That's so fun to say.
Yeah, because
Really?
Lance just received his doctorate. Yep.
Yes. And Lance was the first person to start a soil health division, and he started that over 10 years ago,
Mhm.
I think. Yeah. So, so they've been actively keeping up with any changes that had been made, any research that's been done. And now Rick is working with Lance to look at correlations between like PLFA, which is a microbial biomass measurement, and other things. We can talk about that later. But and the Haney test, or total nutrient digest and the Haney test, and trying to tell more of a story with the data so that we can more completely understand the biology
Okay.
in the system.
Well, I think that's two good points to know. First off is that, it's a lab that's current and is looking at exploring new things,
Mhm.
and that just because your last names are Haney, you're not getting royalties on this to where you're going to be worth $1 million from
Right.
all the soil. Yes. But yeah, I'm glad you brought that up.
Yeah.
So now, what are some things that you would say, I was kind of looking at some things that when you're comparing a Haney test to a standard test, I've used a lot of Midwest laboratories in the past. I have for many, many years. What are some of the things that I'm going to recognize on there, on both, that are similar, maybe even a similar methods? I think one is just organic matter, loss on ignition,
Yes.
that kind of thing.
So organic matter, and I'm
We're gonna pull up the tests right here, and we'll see that.
that way I can run through it.
You can run through it, or maybe you want to do these in a different order. You're the boss. I'm you're asking questions.
Well, let me answer your question.
Okay.
I can do that. So there's a section on the results called other soil measures. And under that is soil pH, buffer pH, soluble salts, excess lime, and soil organic matter. So those are going to be standard run, just like at any other laboratory or any other standard soil test.
So here, this, and I haven't told everybody, but Kim Sheese, our producer, she is going on a long-term adventure on her own family farm. So she did a complete assessment of her farm, and she's going to record all the data, all the metrics, all the investment to really quantify what's going on with regenerative agriculture principles on her own farm. So this was the initial tests that she took on her farm, and we'll probably share some other ones that you've got from other locations later on. But that's why you see a 7.2 pH, which is kind of high for this area, really. So it's had a good lime history.
Mm-hmm.
And if you look at soluble salts are low, that's just nature of this kind of ground, no excess lime. But she's at 2.4 organic matter. You'd like to see that a little better, wouldn't you?
Oh, we'd like to see that improve everywhere, but that's not the most important part to me.
Oh, now wait a minute. That's what the mantra is today.
No.
It's not. It's like, look at my organic matter, and my organic matter is bigger than yours.
Right.
And I'm the best then, right? There's
Yeah.
probably, okay, you want to dive into that a little bit?
Sure.
I bet there's cases where you have high organic matter, but actually poor microbial activity.
Right. So I often use an example of two soils from Missouri where one was recently taken over from conventional and the other one had been regenerative for quite a long time. The one that got turned over from regenerative or from conventional had organic matter of 7.1%, which most people would be dancing.
Wow.
Right. So that is good. The one that was regenerative is in a little bit different area, but it's got organic matter level of 3.1.
Oh, so the other guy's got him beat. He's twice as good.
Right. Wrong. So the important thing to note is that the water extractable organic carbon portion, that food source, which is a much smaller pool than your total soil organic matter, was, I think, 4 times higher in the regenerative soil. So the soil respiration was, I think, double. And I don't have the numbers in front of me, but significant difference. All of the other soil health measurements that we were looking at in the regenerative ground were improved over the conventional, regardless of that soil organic matter number.
Okay, so important takeaway, everyone. Just because your organic matter is a bigger number doesn't mean it's necessarily
Better. Right. And I mean, if you think about Hawaiian soils, really, really high organic matter, very, very low microbial activity,
How do you know
almost
that?
dead. Because we've looked at Hawaiian soils.
Have you sampled Hawaiian soil?
Yes.
I think so. Everyone should know, if they want to learn more about soil, they should take a trip to Hawaii
Yes.
and sample it. And that's part of a continuing education. So there's probably not only a write-off, but tax credits for that.
Yeah.
Yeah. Okay.
Grant, whatever.
That'll work. All right. So let's dive into Kim's test here.
Okay.
We're going to tear it apart.
Okay.
Is that all right?
Sure.
Where do you want to start? Do you want to start, up in the upper left, right, and down? Or do you want to start with your favorite first, go right to Weok?
I think we're going to start on the upper left because I was
Okay.
given instructions.
Kim's very specific.
Kim is very specific.
I know.
Yes, that is
She-
number one.
She's trying to herd cats here. I feel sorry for
I know. Feral cats.
her. Anyway, on the nitrogen part. Now, wait a minute. When I've seen my older tests, there's nitrogen. You get nitrate nitrogen if you pay a little bit, and you get ammonia nitrogen if you pay a lot. And I only get 2 columns, and you've got 1, 2, 3. There's like 10 things here for nitrogen.
Sure.
You got a lot of explaining to do.
So we do traditional nitrate nitrogen, like you would see at another commercial laboratory.
Mhm.
However, it says H3A extract. So that is true. We measure it using the H3A extract. We also measure inorganic nitrogen using a water extract. So we measure total water extractable nitrogen, which is somewhere
Right here a
else.
little bit.
Yes, over to the right, 4th column over under nitrogen,
Mm-hmm.
and then measure inorganic nitrogen. And by difference, we get organic nitrogen, water extractable organic nitrogen.
So it's just math.
It's just that.
You're getting 2 to determine because measuring that fraction's really tough to go after directly. Correct?
Yes.
Okay.
And then we have ammonium as well. And so nitrate and ammonium are run on one instrument. Organic nitrogen's run on another instrument. So when you get a Haney result, you'll see nitrate nitrogen in the first column, then ammonium, and then the sum of those two, which would be your inorganic nitrogen in part per million.
Okay.
If you want to know what that is in pounds per acre, just multiply by 2.
And
And then
that's because there's 2 million pounds per 6 inches or 6 2/3 inches of soil.
Right.
Okay.
under the water extract, you have total nitrogen. So I explained we measure the total nitrogen, subtract the inorganic nitrogen, and you get organic nitrogen in part per million.
Okay. So that's the total land, the 20.1 minus the 13.4.
Mhm.
Okay. Get you 7.3. Well, there's a little bit of
There's a little bit of
wrapping and stuff.
there's a little bit of difference because the nitrate nitrogen on here is from the H3A extract.
Okay.
Okay.
Gotcha.
So then we look at the organic nitrogen to inorganic nitrogen ratio.
So that's comparing the 13.4 to the 7.3.
Right. So
Okay.
you have 7.3 over 13.4 gives you a ratio of 0.57.
What's that tell you? So what and who cares?
Well, I like that number to be over 1
Okay.
because I like for there to be more organic nitrogen than inorganic nitrogen.
Now remember, Kim's not in trouble for this because she did this right when she started farming this land.
Right. And
So we're going to watch this change over time.
right. And this was coming in from conventional, right?
Correct.
Right. So that's a pretty good number.
Okay.
I mean,
For
if you're
conventional.
for conventional, you're starting out with a fairly good soil.
Good. But you
But-
want to see that grow to 1.
Right. We
Where
want
you
to
have
see that
more
grow.
organic nitrogen available
Correct.
More organic than inorganic.
Correct.
Because that's easier for the plant to feed on.
Right. Easier for the plant to feed on and less susceptible to
Leaching.
Yeah. Or volatilization.
Yep. The 4 fates of nitrogen, none of which are good.
Right.
Gotcha.
The organic nitrogen release in part per million, which is next to the organic nitrogen to inorganic nitrogen ratio.
Okay.
So that we can see is the same number as just organic nitrogen.
Yeah. Why is that?
Okay. It's because you have pretty good soil respiration.
Okay. So you got a lot of biological activity going on. So what that's saying is that the release, she's able to release 100%.
Correct.
Roughly of the organic to be plant available.
Correct.
Now, on other people, this would show then that release portion is important because then that's what you can count on for a crop to use.
Yes, you can count on that number being there. And then let's say your soil respiration is really, really low. You would not get credit for all of that organic nitrogen.
So that's how that's calculated, is based on your soil respiration in order to know what that conversion of organic nitrogen would be to plant.
Correct. Yes. And we don't want to shortchange anybody. Yeah. So
because if you said 7.3 and you have poor respiration, person might go ahead and so that's 15 pounds of N. Person might cut back 15 pounds, and then if none of that 15 pounds is available, we've lost on yield potential. Okay.
Right.
That makes sense.
So if there was...
By the way, this is awesome.
Thank you.
I'm learning along with you all. Isn't this great? Mind-blowing. Okay, sorry.
No, it's fine.
Kim can edit that, but I know her, she'll leave it in.
Yes,
so.
probably will. If let's say she had lower respiration and was only releasing 3 part per million.
Okay, so then you'd have 4.3 over here.
Then you'd have
organic and residual, RES.
That's reserve.
Reserve. Okay. Now, reserve's good when we're talking about whiskey and those kind of things.
Right.
Not good here.
Yeah.
Okay, because you want that. The key to the soil is to keep things cycling.
Yes.
Nothing stays forever. There's always change.
Yes, and that is a very good point, because if you take, let's see, these soil samples were taken in June of 23.
Okay.
If you were to go out there right now when it's colder and, coming out of winter.
Right now we're in the first part of March of 24.
Yes. Sorry.
No problem.
You would get different numbers. So soil biology, like you said, it's constantly cycling, constantly changing. If you're doing some sort of soil of fertility recommendations, you want to sample before you plant. If you're going to do a side dress, you want to resample before you side dress, because things change over time. And you might not see as big of a difference if you're doing a standard test over time as you would doing a biological test.
Okay, so you realize you just opened a whole can of worms there. Now we get to talk about. Okay, but hold on just a minute. Let's finish nitrogen first.
Okay.
And then I want to ask you about sample timing, location, and all those things. So, okay.
We got through nitrogen.
We got through nitrogen.
Thing, I am going to jump down to another.
Can I finish nitrogen real quick, though? Then on the far right, it says available N pounds per acre. So 37.2 means the 7.3 of organic N release.
Yes.
Plus the 13 or the 20.1 of there. Where's the rest coming from?
So, so 7.
Oh, that's pounds per acre.
2. It's pounds per acre.
I'm sorry.
Plus
take it times 2.
13 inorganic. Yeah.
Thank you. So it's 7.3 of the release portion of the organic N plus the 13.4 times 2 to get the pounds per acre.
And you can really see it under the nitrogen comparison section.
Now we're dropping down third line in the middle there.
Right. We're dropping down.
So traditional's this is cool.
Yeah.
Yeah. Go for it.
Okay. So traditional nitrogen in pounds per acre would be just nitrate nitrogen.
Correct.
Because most laboratories don't test for
and it's only like $5 to test for nitrate, or $3 at another commercial lab. It's cheap, so we do it.
Right. And I mean, it's good to know.
Sure, but it's not telling you the whole story.
It's not the whole story. So the Haney in pounds per acre is all of the nitrogen that we found.
So the extra
nitrate,
cost.
ammonium, and organic.
Okay.
hmm The difference in nitrogen in pounds per acre is your Haney N minus the nitrate nitrogen N. So using the Haney test, we found an additional 15 pounds per acre.
Okay.
The average value for that over the whole country or even out of country is about 30 pounds per acre.
So we're missing out on 30 pounds, that differential between the Haney test and conventional.
Yes. Yes. On average.
Okay.
So let's say it's
We're-
$1 a pound.
Sure. $30.
30 bucks.
Yeah. And that price will vary, right?
Sure.
But here's the thing. It's one thing, I'm real big on this. It's one thing to have the economic loss, but it's another thing of if we have that extra out there and we didn't use it through the plant, where'd it go? It went to the atmosphere as nitrous oxide.
Mm-hmm.
It went to the water streams as nitrate runoff, causing algae blooms and those kind of things. It leached through to the groundwater. So with nitrates in well water, which are a
Bad.
huge and growing problem because that legacy load is on its way. And then the other thing is it fair to say that the excess nitrogen, and I've said this before, could be wrong, but having excess nitrogen in that system is also going to be hard to accumulate carbon.
Yes.
It'll tend to burn the carbon out of the soil because carbon and nitrogen are always seeking a balance.
Correct.
So I'm not wrong there.
No, you're not wrong.
So excess nitrogen, all that we're trying to do and achieve, we're taking 2 steps forward, 1 step back.
Yeah. Or let's say you're running out of carbon in your soil, you'll have nitrogen immobilization.
Okay, say that again. This is a mind-blowing point here.
Yeah. So if well, you're going to have nitrogen immobilization if you're out of balance with your C to N ratio.
Mm-hmm.
So you want to keep your carbon to nitrogen ratio between about 12 and 15.
Okay.
Yeah.
Now, if you're not between 12 and 15 and you say that you're at 10 to 1, then we're carbon starved.
Right.
And we're immobilizing nitrogen. Okay, so let's talk about what happens when we drop below on that carbon to nitrogen ratio and we have too much nitrogen in the system. That causes it then to look for somewhere to go. So they really has 2 options, you were saying. One is take the carbon in, essentially burn that out of the soil.
Yes.
To get to that,
Get to back to
your 12 or 15 to 1. Or instead of, you're looking at losing it, right? As far as leaching or volatilization.
Okay. Yes, especially if you don't have a living plant. Right. What the microbes are going to start doing is stealing carbon from that total soil organic matter or the aggregates.
And destroy aggregates.
And destroy your aggregates, your water, pore storage, air space, all of that's going to collapse.
So really important to keep in mind on why overapplication of nitrogen can impact that. So this is a discussion that we need to have as we move to higher and higher yields. National recommendations are more and more nitrogen to support these 280 and 300 pounds. And the trouble is we're feeding that nitrogen the same way we always have. Maybe all up front in a side dress, but instead of having, 80 pounds and 80 pounds to support a 200 bushel diet, now we're putting out 150 at a time. These high loads. Talk about what happens with nitrogen when we're doing these high loads and what is that correlation to? We're having this decrease in water infiltration and we have this surface sealing crusting issues going on. All of a sudden, that's related to this nitrogen and how we're managing.
Right. And part of that is the salts in the fertilizer.
And salts are a dispersal agent.
Yes. And then you're dumping a whole bunch of nitrogen into the system and throwing it off balance.
In one shot.
Yes. So you're throwing all the microbes off.
I've always said that any nitrogen application never exceed 80 units at a time.
Yeah.
What do you say?
I don't tell people what to do.
You don't tell people what to do?
No.
I just try to say if you get greater than 80, you cause and I think I stumbled across some research years ago that shows that you change the microbial community makeup if you overload the system.
I can see it because you're going to make the nitrifiers lazy. So, well, it's the same with, well, let's say you do corn on corn on corn. Well, your soil is going to adapt, your microbes are going to adapt to corn on corn on corn. And your diversity is probably going to shrink.
Correct.
If you're out of balance, your diversity is probably going to shrink, or some of it's going to go dormant. Some of the microbes are going to go dormant. And you want a really diverse microbial community so that you can be more resilient, because some of them are going to function during a drought that wouldn't function when it's adequate moisture. And so you want to have that diversity there so that things keep cycling and moving.
So that's why a crop rotation is important.
Crop rotation.
That's why diverse cover crops are important.
Correct.
Is to increase the diversity and quantity, but mostly diversity of the microbial community, so that when you get a out of normal range event, those other communities step up to take over for the lazy nitrifiers.
Yeah, to take over for lazy microbes.
No lazy microbes here.
Right.
So you heard it, Kit, and everyone. Liz is a microbial. I don't know what you want to call that. She makes sure they work.
Yeah.
So back to how does that? I want to back up a step on that. Those high nitrogen rates. We see producers are getting surface sealing and are getting longtime no-tillers that are going for higher and higher rates of nitrogen. They are regressing, to vertical tillage or something to break up that surface. Is that because we don't have the right balance of carbon when we're feeding nitrogen to the system?
I think it could be a lot of different factors.
One of those.
That could be one of those.
It's not the only.
Yeah, I don't know. I mean, especially if you're long-term no-till and no-cover crop, I would rather see some form of tillage in a cover crop
that is no-till with nothing.
Correct. Yes. And that's because we want those plant roots in the ground all the time, and the diverse plant roots, because each plant's going to feed a completely different set of sugars and plant root exudates, like buckwheat, they feed the little rock eater bacteria, and so we get release of phosphorus from calcium. So you want all those different plants in there to help everybody function.
And when you think about it, if you're a no-tiller growing corn, 110-day corn, once you hit tassel on a corn plant, there's not hardly any carbohydrates coming down to those roots, because the ear is the primary carbohydrate sink. Almost everything gets captured. And you've probably seen the studies where total root length actually shrinks, post ear formation, because there's just not enough. It's remobilizing energy from the roots up to the ear.
Well, they're coming from the bottom up.
Yeah. So really, I mean, you've got, and plus on the front end, if we're planting, let's say April 20th here in the Midwest, kind of a common date, you really don't have the nodal root system or any sort of root mass to that plant until about May 20th.
No.
When you're at V4, when we start to really set a lot of nodals. So you got between May 20th and we tassel around, let's say July 20th, just for easy math. We've got 60 days of active root growth.
Yes.
I think there's 365 days in a year.
Right. Last time I checked.
Last time you checked. This year we got 366. So anyway, we're missing out on a huge opportunity because of that, either in corn or soybeans. Soybeans, because they just don't have the root mass. Right. That's something important to think about, is we're not adding carbon to that soil other than 60 days a year. Other than residues from but residue is not as fun. It's not your
it's not
carbon.
Alive.
Right.
Yeah.
So, okay. So anything else on nitrogen before we kind of wrap up this segment on nitrogen?
I don't think so.
So I think
we can talk about carbon and nitrogen ratios more, but we should probably wait till we talk about it.
Yeah, we'll take a break for now. But okay. I think this is awesome. I think when you're looking at and considering soil tests, nitrate, nitrogen, many of you, especially in western Kansas, I know we pull nitrates all the time just to see what we got residual because we don't get enough water to leach it through. But this is looking at ammonia and, like you said, the organic nitrogen, and those tests are all combined and included in here. So I think, first off, there's a test value associated with this if you compare it to a conventional lab. But then I love how you're looking at the different fractions. Worldwide, you're seeing a 30 unit per acre savings on all the tests. Now, some will be 0, some will be probably 100. But I think that's good to know what that benchmark is so that we don't, like I like to say, farmers, we know that if some is good, more is better. And in this case, we'd be looking at applying 30 pounds more than what we'd need on average. Here on Kim's farm, it'd be 15 pounds more than what we need. And nobody wants to be a moron. So we're going to skip being a moron, use the best technology available to us. And I think just this nitrogen portion can make a lot of money for you and make your soil better over time because we're not burning the carbon out of it. Okay, so now we're going to venture into phosphorus and learn a little bit more about what makes the Haney Soil Test unique. And this is certainly one of those areas. So using Kim's soil test here, what do you see going on? And walk us through how the H3A extract works and some of those differences there.
Yeah. So we use the H3A extract instead of harsh chemicals, which we discussed a little bit during the opening.
Mm-hmm.
So I don't know how much more you want me to go into that, but I will if you want me to.
Now that's clickbait. We're going to make them go back and watch the opening. Okay. Anyway, go ahead.
Watch the opening, people.
Yes.
So we have a total phosphorus number, which is inorganic phosphorus plus organic phosphorus. Most laboratories don't test for organic phosphorus. And what we're doing is using 2 different instruments to measure phosphorus off of that same extract instead of just one. So most laboratories use colorimetric readings for inorganic phosphorus, whereas we're using 2 different methods. And this is all published information. So we're running organic phosphorus.
Don't worry, nobody that has read that stuff,
Yeah, I know.
Okay, so
I'm not giving away any trade secrets. Is what I'm trying to tell you.
Okay.
Yeah. So we run phosphorus through an ICP, which is an inductively coupled plasma machine.
That's why we say ICP.
Yes.
Okay.
Yes. And that gives us the total phosphorus, and then the inorganic phosphorus is measured on the colorimetric reader, and by difference we get organic phosphorus.
Okay, that same method again of get the total, get one fraction, and then we can calculate what the other is.
Yeah.
Okay.
Yeah.
Very good. So 24.8 in Kim's test here, that's pretty high testing phosphorus for this neck of the woods on a timber soil.
It's good, and especially if you're used to running, say, malic or something, you'd be getting higher values probably. But the pH of the soil is really good. So
say that again.
The pH of the soil is really good. So you're probably not getting too much tie up with calcium, iron, or aluminum.
Right. So we get calcium tie up when we're in high pHs.
Right.
And then we're going to get the iron and aluminum when we're in lower pHs. Okay. Mm-hmm. Very good. You look at this, we got inorganic is 21. So yeah, 3.8 is the difference there. We talked about an organic nitrogen, much more plant favorable. Same thing, organic phosphorus.
I haven't seen research on that.
Okay.
But I do know that when the microbes are chewing on that water soluble organic carbon portion, they are going to be chewing up organic phosphorus and releasing it to the plant.
Correct, because nothing exists as one thing.
Correct.
In nature.
Right.
As much as we try to silo stuff, everything is interactive.
Correct.
Okay.
Yes.
And then what, again, we're back on the third column there. We got the organic phosphorus. That's 3.8 parts per million. Then we got the organic phosphorus release, 3.8. So that's another, if you're in a different pH, would that release then be affected, or what affects that release?
Again, it's microbial activity.
Okay, because she's got good microbial activity of all the organic phosphorus that's there, all of it should be predicted to release to the plant.
Yes.
Okay. And then that same thing, organic phosphorus residual there, or residual, is that the right term? Or
reserve.
Thank you. So that gives us an idea. So obviously in this case, probably very few crops, if any, would need any sort of applied phosphorus at these levels.
Right.
So, okay. Yes. Any other thoughts on phosphorus? I think the real key is the extraction method using the oxalic, malic, and citric. See? I'm learning. I only got 2/3, okay? So I'm learning right along with you folks. But those extraction methods that more mimic nature. Okay. let's move on. What do you want to move on to next?
Well, I got a lot of questions the other day about phosphorus stratification.
Oh, there you go. We have my neighbor is Marion Kelmer, and he's made all the news in No-Till magazine about running a plow because of stratification, and he's my buddy. Anyway, talk to us about stratification.
Well, I've seen, I mean, a lot of that's going to happen because of improper phosphorus application methods.
Yes. So
Yeah.
phosphorus moves how far in the soil?
I don't know
That's
how
a good
far,
question.
but it's definitely not as mobile as nitrogen.
Sure.
Right.
Yeah.
So the calculations even for determining the pounds per acre are more complex of what's available for phosphorus because of that stratification. But you want to take a 0 to 6 inch sample so you can see what's going on in that upper management zone. And that phosphorus is what's available in that 0 to 6. If you're worried about stratification, go pull a couple samples from 0 to 2, 2 to 4, 4 to 6. You can go down 6 to 8 if you want to. But make sure you label that on the bag if you're going to go take samples like that. And then you can see where everything resides.
And I think it's important too to know, talk to us a little bit about where phosphorus comes in. Okay, so first off, the very surface of the soil, especially if we don't have residue, it's dry. The microbial activity and the root activity on the surface is next to nothing, correct?
Well, you should always have higher microbial activity at that interface between air and soil.
Because there's more oxygen.
Yes, but if you're crusted over, it's going to be low in the top, but I guarantee it's going to be low down below as well.
Because you're suffocating them. There's no oxygen source for the microbial
Right. And the
respiration.
water can't get in, and they live in a subaquatic environment.
Okay.
So,
But what I was getting at is on the very surface, let's say we're in a long-term no-till situation.
mhm.
We're broadcasting, typically a dry, or maybe they're putting on a liquid broadcast or something for a long period of time. So we get a lot of phosphorus accumulation. And I've read some places where it moves maybe a millimeter per year, so it's not very mobile. But the roots of a corn plant or any plant aren't typically right at the surface because it's hot.
Right.
It's dry. It cracks and prunes the roots. They're typically, the top half inch is really hard to find any roots. Especially if you don't have soil cover.
Right.
So we could be pulling in, like you're saying, it's the stratification. There could be a 300 part per million concentration at the very
Right.
top. And yet it's being averaged over the whole 6 inches.
Right.
But that real very top is just not plant accessible because
Right.
the roots don't
The roots aren't there.
grow
And,
right at the surface.
and you probably don't have a big fungal community right there at the top if you're dry and
Right.
worn out.
Oh, let's talk about actinomycetes and
Yeah.
residues and stuff and that fungal community right at the surface.
Right. So, I mean, like when I looked, like we did the 0 to 2 inch sampling with on Russell's fields,
Mhm.
and he had really good phosphorus all throughout that upper 6 inches.
Okay.
So why is that? Well, one is probably his method of application. He does things in furrow 2x2,
Mhm.
and then also his soil's actively churning and moving because of earthworms.
Okay.
And so that soil's being moved around.
And he's no-till.
He's no-till.
Right.
Yes.
So one of the keys I've always done on my own farm, we recommend to everyone is anytime you put phosphorus on, put it into the soil.
Yeah.
So if you're with colders on your planter, if you're strip tilling, putting it in with the strip till band. If you're doing full tillage, but if you're doing full tillage, put it on and incorporate it ahead of that tillage event. If you're side dressing, with coulters, put it on then. If you're putting it on Y drop on the surface, that's probably not ideal because, again, we're on the surface. But anytime you have something where you can put it into the soil,
Yes.
you're saying definitely do that.
Yes. The same thing with like manures as well.
You have a little more hope with the manure, though, because of
Yeah.
your night crawlers.
Yes. So, and if I guess I think of it from most people's soils aren't biologically active.
Okay. But night
But-
crawlers do like that as a food source, and they'll
Yeah.
come up, grab it.
Come up, pull it down, which is
Okay.
good. And then liquid. I mean, it is more active and available, but like, let's say you're in a
Liquid would be, yeah.
yeah. Let's say when you're in a system where you're just going no-till, starting out, you've been conventional, you may not get that movement in, and you need a shot of that carbon, like from a manure source or compost or whatever.
Well,
You
hold
want
it.
to get that.
You mean manure is more than NPK? Are you
The most
kidding me?
important part is carbon.
Oh, it's C.
Yes.
I got you.
Yes.
Okay. And so that manure gives you a start, especially if a person's converting from a conventional soil to
Right.
long-term no-till with no
Right.
cover crops, or just long-term tillage with no cover crops.
Yeah.
Manure is a great way to jumpstart that system.
Correct. And we, we work a lot with transitioning growers.
Mhm.
We do work with some long-term regenerative, but like what we always tell people, if we're still coming to your farm and consulting 5 years from now, we haven't done a good job. So that's why generally we're working with people that are transitioning
Gotcha.
and getting them jump started.
So now because phosphorus and manure go hand in hand, different forms of manure and how they work, and especially when in regards to carbon. So a lot of the liquid manures have gone through anaerobic digestion in hog pits and such, which means the carbon in there is converted to methane and it's gone. So a lot of the liquid manures are typically not great sources of carbon. Is that correct?
Well,
I don't work with it every day. Like
I don't know. I haven't really tested that. We did do some tests like with composted dairy manure versus chicken litter.
Mhm.
The dairy manure was better.
Mhm.
Mushroom compost was really, really good. But and I had, the reason I'm bringing it up is because I had the same question a few days ago, and the biggest thing you can do is try it out on your farm with different application methods, and then leave a check strip so that you know it, which would mean zero application, so that you know those things are making differences and what differences they're making, and then soil test.
So if you're looking at an ideal manure or a compost, what would you say? We know kind of what NPK levels are because that's what we've always focused on. What would you like to see in the carbon ratios? Do you happen to know that off the top of your head?
So, I mean, it's going to depend on where you're starting at with your soil. And so I don't have a definite answer for that. Let's say you have a really low carbon to nitrogen ratio in your soil. You're going to want to find a source that has higher carbon.
Higher carbon, yeah.
So have your manure tested.
Okay.
Yeah. And
That would be get your poop in a group.
right.
Okay.
Yep. And everybody wants ranges and numbers. And I want to reiterate, it's a completely,
So the concept is what we want to learn here.
the concept is great. But what everybody needs to keep in mind is that it's going to be completely different here in Illinois than it is in Texas.
Mhm.
I can't get dairy manure down there very readily. We have
And it's just a long haul.
it's a long haul. We have feedlot manure, so you
Yep.
gotta work with what
The source you have,
with
right.
what you have within your budget to get
Mhm.
that stuff there.
Yeah. And then the other, there's just a myriad of things you can do to create on-farm compost. You could take your
Sure.
feedlot manure, and if it don't have enough carbon to it, you could, take old straw, compost it together, create a higher carbon product. But yeah, that's all very site specific. But don't overlook manure as a way to jumpstart your system. Is the real
Right.
takeaway that everyone can
Yes,
look
and
at.
you can use these soil tests to determine the efficacy of those things,
And
of
the
those
neat-
additions. Yes,
Right. So you can see that, hey, in this situation, an addition of manure would be really important. And then once you have done it, you can get the feedback loop to know that that was a good investment.
correct.
Okay. Very good. Anything else on phosphorus or manure that we should cover at this moment?
I can't think of anything right now.
Where do you want to head to next, Liz?
Well, we already talked about other soil measures, so we can skip over to the fertility section,
Okay.
which is H3A extract.
Yes.
Okay, so we use the H3A extract instead of maybe ammonium acetate or EDTA or now malic. People are using malic as a universal extractant.
Which I never did understand because you're using one extractant to come up with the negative ions and the positive ions. And I'm just like, how does that work?
Well, the nice thing about
It's a
H3A,
great guess.
well, the nice thing about H3A is you can do that because it's what's actually going to be available in that root zone.
Correct.
And that's the most important part. It's
Right.
what's happening right around those roots.
I was referring to malic, just
Yeah.
one for everything.
Oh, yeah.
It just never did make sense. So anyway,
Yeah.
walk us through this and how that the extract that simulates the root extracts and how that works here.
Yeah, so it's the same concept as these acids that the plants pump out are going to start dissolving minerals. They're going to dissolve other things that release nutrients, and then through microbial activity, there'll be some more that's available as they're fed by the sugars in the plant. And you get the same types of numbers or analysis that you would get with a standard test. So you get your potassium, calcium, magnesium, sodium, zinc, manganese, iron, copper, aluminum, and sulfur. The one thing we don't do is boron, and that's because of a glassware issue.
Well, yeah, that is kind of a funny story about the boron and glassware and how boron's used to temper glass, right?
Right.
And you'll pick it up in your soil samples.
Yes, you can pick it up with the acid extract, any type of acid.
How do you do boron?
Hot water soluble boron, but you just have to use different glasses. So you don't use glasses.
Gotcha.
Yeah.
Gotcha. Okay.
And I did have a farmer ask me if he could take glass and crush it up and put it on his field to get boron. He was kidding. Thank God.
You get all kinds of great questions. So back on this. So this is going to be very similar to what maybe people are used to seeing before. Let's just comment on Kim's levels here. And other people, I've come from the old school where we're used to seeing this in a percent due to cation exchange capacity and then percent of that. How does that blend into this test? Or that's just, it's a calculated number, the percent base saturations.
Right.
Is that part of this?
So no, we don't do percent base sat. We look at ratios often, like the calcium to iron and aluminum ratio.
Okay.
That's one of Rick's favorites.
Why is that?
It's basically just showing the balance of, it has a lot to do with pH, but the balance of calcium to iron and aluminum, the higher that ratio is, the higher your pH is, the higher you're going to get high up with phosphorus. And then if it reverses, you have a lower pH, you'll get more phosphorus tie up with iron and aluminum.
And this is another example of, you normally don't get an aluminum test on most soil tests unless you request it. Okay. So that's kind of interesting. And then, so looking at Kim's situation here, 36 pounds of potassium or 36 part per million, 72 pounds. What's your thoughts on that? Adequate?
Yeah. And so I don't know the texture of these soils because I didn't touch them, but
do we have that in here?
I don't think so.
Okay. Anyway, so talk about texture and how that relates to potassium. This is probably a silt loam out here.
So the higher the percentage of clay that you have in the soil, the more potassium you add, the more you're going to tie up potassium. Because, and this isn't my research or my thought, this is Dr. Mulvaney's. They noticed this because they went out and tested a field, hired someone to come put potassium on. They retested it and thought that the sprayer didn't go out there, or whoever was applying it, because the numbers dropped the second time they tested it. So they went out and reapplied the potassium and the numbers dropped again. And so potassium is pretty small and it's replacing things in those clays, and then the clays collapse on that potassium and it's not available anymore.
Okay. So now back to flocculation dispersion of clays. Single charge potassium's a lot like sodium. Now, sodium's got a higher charge capacity than potassium, but whatever, 2.13 versus 1.78, something like that. So
on that guy.
Yeah, right. So, I mean, that actually acts just like, salt that farmers in the West are facing, causing the soil to essentially collapse on itself.
Right.
Same thing. And so now a good fertilizer dealer, though, would say that, build and maintain. We have to just keep adding more, right? How is that message not out there?
Well, most people don't run a total nutrient digest. So if you have a grower, or if you're just curious as a farmer yourself what your total reserve is, you can send in a sample and do a total nutrient digest, and it'll tell you how much you have available for the lifetime of that soil if you never fed it again.
Correct. Now, that's important. So, and we don't have that test with us in front of here, but let's say we got the 36 part per million, 72 pounds. The total in this soil in in Illinois, you got a total extractable, you'd be closer to probably 7,000 pounds.
Right. So why do you need to keep adding more?
So we're showing all this is showing is that roughly 1%, let's just say for an example, 1% is plant available. 99% is tied up in the mineralogy of the soil.
Right.
Part of the feldspars and now I'm using words I don't know. Part of the minerals in the soil is bound.
Yes. So it can be in a mineral form or it can be trapped in the clays. And you can exchange
between the clays. Like if you get those
clay,
2-to-1 vermiculite, that actually. So Southeast Kansas is really known for this, where they have those clays that just trap the gas.
And in Texas, where I'm at as well.
You get that good stuff too?
Oh yeah,
awesome.
Yeah, but like if you're in Western Oklahoma where it's sandy and you get a number showing that you might need some potassium to grow your crop, you could do it. Yes, do it.
So if you run into a higher clay situation and you see you have a number that says you need more potassium, the answer may not necessarily be more potassium.
Right.
Instead, you need to look at increasing microbial activity. Right?
Increase microbial activity and maybe do foliar type of stuff.
To avoid the soil system. At key points that potassium is needed. Potassium is needed during a stress event or during reproduction or those key events
stages.
And just to give it the little supplement that it needs to keep root growing, to mineralize more from the parent soil.
Right.
You just made a lot of fertilizer dealers unhappy.
They love me anyway.
I bet they do. Use less on. You're a less on instead of a moron. Right? There you go. Talk to us then about, so these, a lot of things that come up is calcium magnesium ratios. Okay. So help us understand what that means here when we're not, I was kind of used to, I'd like to see a 10 to 13% base saturation magnesium in an ideal soil and a 75% plus calcium base saturation. What do we need to look at in this regard with it?
Generally, we look at just the ratio. So
part per million to part per million
to part per million, keeping it around 3 to 1.
3 to 1. So
when that ratio shrinks, you've got more magnesium probably than you need, and your soils might start collapsing.
Correct.
Yeah.
Because again, hydrated radius of magnesium is bigger than the hydrated radius of calcium, so that causes that whole aggregate structure to get essentially kind of blown up, right? I mean, it separates clay particles from each other, causing them to collapse.
Repel each other.
Yeah. Okay. What else should we look at here? I'm surprised. Okay. Most labs I'm used to, if you have a zip code that's east of the Missouri River, they don't even test for sodium. Doesn't come up. Or if the pH isn't above a certain amount, they don't run the test. That's a standard test that's run all the time. And a lot of that sodium's probably coming through maybe a little bit from parent material, but here we're in a high rainfall area with good, that can indicate maybe poor internal drainage or nitrogen or phosphorus applications over time, or sodium or potassium applications over time. There's salts that come through in those.
But that's never good. Seven,
no problem at all.
Yes.
When do you start worrying about sodium?
Only in New Mexico. No.
Perfect.
Out west. Yeah.
But what part per million do you see typically?
I don't remember off the top of my head.
Okay.
Because I haven't looked at those.
And that's going to be a ratio thing to calcium too.
Right.
Zinc, 0.88. We'd like to see that just a freckle higher.
Right.
Are you in the 1 camp?
No, I'm not in any.
You're not in any camp?
No.
Manganese 30. That's actually surprisingly high.
Yeah, it is.
Most of these in long-term no-till, manganese is lower because we typically use a great chelating agent for manganese. I mean, everything we do always has a side effect, right? So it's a matter of picking the things that have the least side effect. But in the case, glyphosate, we know likes to immobilize zinc and manganese. So manganese at that level is good. 82 iron, plenty, and not too much.
Right. Both iron and aluminum look good. Sulfur looks good.
Copper, 0.28, that's fine.
Yeah.
And then another thing you like to probably look at is copper magnesium ratio.
Yeah.
Because if you get too high on copper, then you have manganese.
So I'm going to be 100% honest. I am not a micronutrient expert by any stretch of the imagination.
Okay. No, that's fine. But I mean, that's one of those things we'll run into on copper and manganese is you can show some manganese deficiency. And this will apply more on like dairies that use copper foot baths all the time. So they'll have a lot of copper sulfate effluent in the lagoon water. So we'll see manganese deficiency sometimes because they compete for places in the plant. Any other thing on the other cations here?
No, I would just say, like, when you're looking at, if you do see results that are off like that the ratios are off, you'll probably see a decrease in respiration as well.
Yeah. Okay, let's talk about that. Because, again, the soil just isn't this aquarium with sand in it, and each different grain of sand is a different element, and that's how the plant, I mean, that's the visual farmers have, or a bunch of marbles of different colors, and each element's a different color. This is all driven by microbial activity. So as your microbial respiration decreases, the likelihood of plant available
nutrients decrease. Right.
Which requires you then to buy it instead of utilize it.
Correct.
Okay. That's why we're doing what we're doing to encourage healthy soil so a farmer can use more of what's actually in their land versus having to buy and apply.
Right.
Okay.
Because the natural system, I mean, if you want to know what the potential of your soil is, go to a fence row or the wood lot that hasn't been cleared and take a sample there and see what the natural system has been doing. And then take a sample from your row crop field and you're going to be surprised. Probably. Respiration will be higher in the fence row. Nutrients will be higher in the fence row. It's always.
So you're saying we've done a fair share of mucking up things.
Yes.
All right. Anything else on
we're doing the best we did.
What? They
were doing the best that they did, knowing what they knew.
That's right. Now that we know more, we can do differently. Anything else on the fertility section?
No.
All right. Should we move on to soil health?
Thank you for listening to AgEmerge Podcast 173 and Part 1 of Exploring the Haney Soil Test with Liz Haney. Join us for AgEmerge Episode 174 for Part 2. Until then, be sure to register for the 2025 Big Soil Health event hosted by Soil Region.